Welcome to the world of data science, a fast growing field transforming industries from personalized shopping recommendations to predicting natural disasters. I'm Shilpi P. Gonzalez, an academician and a programming and data science instructor. In this course, you will learn the foundation of data science, its real world applications, and the tools and techniques used in the field. We'll explore data design, essential computational tools, and the data science lifecycle. By the end, you will be equipped with the knowledge to start your journey as a data scientist. Let's begin. What is data science? As we can see in the slide, data science is the application of data centric, computational, and inferential thinking to understand the real world problems and to solve those things. There are so many definitions that is available for data science. In precise, we can say like data science is the process of extracting insights and knowledge from data. And the data can be of various types like structured, unstructured data. As we go further in detail regarding the data science, we'll see what are the different types of data that are available. So what are the key steps that are involved in data science? As you can see in the slide, data science it includes a variety of platforms required for the computation of a particular parameter like starts from the fundamental elements of statistics, mathematics. So using the method, we can do pattern recognition, we can mine the data. It uses certain machine learning parameters to extract meaningful insights to predict the future, and it merges with artificial intelligence neural networks in order to visualize certain data. There are hypothesis testing, data modeling is there, big data solution engineering, exploratory data analytics, and modeling and prescriptive analytics. Why is data science important? Data science is crucial because it helps in decision making, automates process, and uncovers trends across various industries. By analyzing large data set, data scientists can identify patterns, predict outcomes, and provide insights that can inform business strategies. For example, in the healthcare industry, data science can be used to predict patient outcomes, identify high risk patients, and develop personalized treatment plans. So, what are the various processes that are involved in data science? The data science process involves several key steps, including big data, classification, analysis, statistics, solving, decision making, and knowledge. First, data scientists collect and process large data set from various sources. Then they use machine learning algorithms and statistical techniques to analyze the data and identify patterns. Next, they use data visualization tools to present the findings in a clear and concise manner. Finally, they use insights gained from the data to inform business decisions and drive innovation. The benefits of data science are numerous. It can help organizations improve efficiency, reduce cost, and increases revenue. For example, in the retail industry, data science can be used to predict customer behavior, optimize inventory levels, and personalize marketing campaigns. Hence, we can say like data science is a powerful tool that can help organizations make informed decisions, improve efficiency, and drive innovation. As data continues to grow in volume and complexity, the demand for data scientists will only continue to increase. Key components of data science. Data science is a field of study that uses mathematics, programming, that is computer science, and domain knowledge to extract meaningful insights from data. Data scientists would apply machine learning algorithms to data such as numbers, text, images, videos, and more to produce artificial systems that perform tasks that require human intelligence. Using the system, we extract insights from the data and use them to make better decisions in various situations. We live in a world that is full of data. From traffic cameras to big corporations produce tons of data every day, every minute. Just one click on the Facebook post may save lots of information about that click. Data science versus data analytics. Data science is a broader field and includes prediction. It consists of various aspects such as Python, machine learning, computer science, structuring data, big data. Whereas in data analytics, it is more about analysis and reporting. It involves Power BI tools, SQL, communication, domain expertise, and statistics, and lots more. Data science and data analytics are two terms that are often used interchangeably, but they have distinct meanings. Data science is a broader field that encompasses a wide range of activities, including data collection, cleaning, analysis, modeling, and visualization. It involves various techniques and tools to extract insights and knowledge from data with the ultimate goal of making predictions or informing business decisions. On the other hand, data analytics is a more focused field that deals with analysis and interpretation of data to extract meaningful insights. It involves using statistical and mathematical techniques to identify patterns, trends, and correlation within the data and to communicate these findings to stakeholders. While data science is concerned with the entire data lifecycle from collection to deployment, data analytics is primarily concerned with the analysis and interpretation of data. Data science is often seen as a more technical field requiring expertise in programming languages such as R and Python, as well as knowledge of machine learning algorithms and data visualization techniques. In contrast, data analytics is more focused on the business side of things, requiring strong communication and interpersonal skills to effectively convey insights to stakeholders. Data analytics must be able to closely work with business stakeholders to understand the needs and develop solutions that meet those needs. Despite these differences, there is a significant overlap between data science and data analytics. Both fields require strong analytic and problem solving skills, as well as the ability to work with large data sets. Additionally, both fields are critical to driving business success in today's data driven world. In terms of tools and technologies, data science often involves working with big data technologies such as Hadoop and Spark, as well as machine learning libraries such as scikit-learn, TensorFlow, or PyTorch. Data analytics, on the other hand, may involve working with business intelligence tools such as Tableau and Power BI, as well as statistical software such as R and SAS. Overall, while data science and data analytics are distinct fields, they are closely related and often overlaps. By understanding the differences and similarities between these fields, individuals can better navigate the complex landscape of data driven decision making and make informed choices about the career paths and skill development. What is the difference between data scientists and data engineers? Data engineers ensures smooth data flow from source to destination, whereas data scientists extract value from data through analysis and modeling. Coming to the collaboration part, they work together to define metrics, design pipelines, and ensure system integration, whereas data scientists should write reusable code for engineers. As we can see from the comparison table, like data scientists, they are business focused. They analyzes data and build machine learning models, cleans and prepare the data, and defines the data pre-processing. Whereas the data engineer is operation focused rather than business focused, and it provides machine learning models with data. It moves the data and implement data processing. In a real world application, consider the case of a retail company. Data engineers would design and implement a data warehouse to store customer purchase data. Data scientists would then analyze the data to identify the trends and patterns in customer behavior. The insights gained from the analysis would be used to inform business decisions, such as which product to stock and how to target marketing campaigns. Coming to the role of data engineers, a data engineer focuses mainly on data architecture, data pipelines, optimizing storage and transfer. And the key responsibility includes their reliable, scalable data systems. Now, coming to the role of data engineer. A data engineer architects the digital world. They are the real world architects. Design databases, they set up pipelines, ensures data accuracy, optimizing performance, anticipating growth, troubleshooting, and security. Data engineers design and build a digital infrastructure that supports an organization's data driven decision making, creates and manages databases to store and retrieve data efficiently. They also create and manage data pipelines to move data from various sources to its final destination and ensures that data is accurate, complete, and consistent. They also optimize data systems for performance, scalability, and reliability. And they anticipate for and plan for future growth and changes in data volume and complexity. And they also identify and resolve issues with data systems and ensures the security and integrity of the data. In a retail company, data engineers would design and implement a data warehouse to store customer purchase data. They would create data pipelines to move data from various sources such as point of sale system and online transaction to the data warehouse. They would optimize storage and transfer to ensure that data is stored effectively and quickly transferred with security, and also ensures data accuracy to implement data validation and data cleansing process. They also optimize performance by tuning database queries and optimizing data processing workflows, and also anticipate growth by planning and for future increases in data volume and complexity. So, as well as they troubleshoot and secure data systems by identifying and resolving issues. In conclusion, we can say like data engineers plays a crucial role in designing and implementing reliable, scalable data system that supports an organization data-driven decision making. They focus on architectures, data pipelines, and optimizing storage and transfer, responsible for data accuracy, optimizing performance, anticipating growth and troubleshooting, and securing data systems. By understanding the role of data engineers, organization can better leverage their data assets and drive business success. Coming to the role of data scientist. A data scientist focus more on extracting insights, that is, identifying patterns, trends, and correlations in data to inform business decisions. Predicting models, that is, in building predicting models, that is, creating mathematical models that use historical data to forecast future outcomes. They also focus on automating decisions, using data and algorithms to make decisions without human intervention. Collaborate across teams to drive data driven solutions. Working with cross functional teams to identify business problems, develop solutions, and implement data driven strategies. Coming to the different roles in data science, analyst. They are responsible for analyzing and interpreting data to inform business decisions. Data scientist, responsible for extracting insights, building predictive models, and automating decisions. Data engineer, they are responsible for designing, building, and maintaining large scale data systems. Machine learning engineer, responsible for designing, building, and deploying machine learning models. So, coming to the real world application, consider a retail company. Data scientists would work with the marketing team to analyze customer purchase data and develop predictive models to forecast sales. They would collaborate with the IT team to design and implement data pipelines to move data from various sources to the data warehouse. They would work with the operations team to automate decisions such as inventory management, supply chain optimization, and they also use machine learning algorithms to build predictive models that can detect anomalies in customer behavior and prevent fraud detection. Data scientists plays a crucial role in extracting insights, building predictive models, and automating decisions to drive business success. They collaborate across teams to drive data-driven solution and work closely with other roles in data science such as data analytics, data engineers, machine learning engineers. By understanding the role of data scientists, organization can better leverage their data assets and drive business growth. So what is basically a difference between data scientist and statistician? Data scientist handles large data. Data scientist works with vast amount of data, often uses advanced tools and technique to process and analyze it. And the focus on automation and machine learning tools. They uses machine learning algorithms to automate tasks and identify patterns and make predictions. Whereas in the case of statistician, they uses traditional methods like surveys, experiments. They rely on established statistical methods such as surveys and experiments to collect and analyze data. And they aim to improve and fit simple models. That is, the goal is to develop and refine simple models that accurately represent the data. Coming to the comparison table, the table of in the image represents a visual representation of the difference between data science and data statistics. Although the table is partially filled, it appears to cover various criteria including definition and scope and objectives. Data science is a field where data scientists extract useful information from raw data using different methods. Whereas in statistics, it is a mathematical discipline of collecting, analyzing, interpreting data to make some predictions. Whereas in data science, it is having a broader scope and covers data collection, analysis, modeling, and so on. Whereas statistics, here it primarily focuses on data analysis, inference, and probability. Coming to the task of data scientist. So, here in the case of data scientist, the major job role is like the job responsibilities is like they need to data collection and cleaning at scale, large scale. They need to experiment with machine learning models, algorithm implementation for automation, and creating automated predictions and actions. So, as we can see in the diagram, the major responsibilities are we need to collect the data. First, we need to collect the data. After that, we need to do EDA on that data, that is exploratory data analysis. So, in that, data cleaning is there, data feature engineering is there, like uh, feature reduction can be there. So, what after getting a clean data, we need to do data analysis and we need to build a model, like we need to take some machine learning models based on the corresponding situation. Either we need to take a classification model or a regression model. Then we need to visualize those particular data. After that, we need to report that like documentation and we need to present it to the stakeholders. These are the major tasks of data scientists. What are the major examples of automation in data science? Some examples are listed here, like analyzing NASA images for new planets, autopiloting planes and cars, Amazon book recommendation, Facebook friend suggestion, simulating molecules for drug discovery. Now comes to the data science application across various industries. Data science is used in marketing, social media, automation industry, travel industry, healthcare industry, in the credit and insurance industry. In marketing, data science helps business personalize the campaigns and target the right audience. Social media platforms uses data science to analyze user behavior and provide personalized content. The automation industry relies heavily on data science to optimize processes and improve efficiency. In the travel industry, data science is used to predict demand and adjust pricing accordingly. The healthcare industry benefits from data science in disease diagnosis and treatment. Finally, the credit and insurance industry uses data science to assess risk and make informed decisions. Coming to the more example of automation includes early epidemic detection, real-time home value estimation, matching ads to users, credit card and tax fraud detection, weather forecasting. Early epidemic detection is a critical application of automation in the field of public health. By leveraging machine learning applications and data analytics, healthcare professionals can quickly identify patterns and anomalies in disease outbreaks. This enables them to respond promptly and effectively, reducing the risk of widespread transmission. The various types of automation includes robotic process automation (RPA), business process automation, industrial automation, home automation, cognitive automation, autonomous automation. So what is robotic process automation? It involves using software robots to automate repetitive tasks such as data entry, data processing, and customer service. Whereas in business process automation, it focuses on streaming business process by automating tasks, workflows, and decisions. Whereas in industrial automation, it applies to manufacturing and production environments where machines and robots perform tasks that were previously done by humans. Whereas in the case of home automation, it involves controlling and automating various aspects of life such as lighting, temperature, security, and entertainment system. Whereas in the case of cognitive automation, it uses AI and machine learning to automate complex tasks that require human like intelligence such as decision making, problem solving, and learning. And in the case of autonomous process, it operates independently without human intervention using sensors, GPUs or other using other technologies to navigate and make decisions. In conclusion, we can say automation has numerous applications across various industries, from healthcare to finance to advertising and weather forecasting. By understanding the different types of automation and their examples, we can appropriate the significant impact automation has on our daily lives and economy as a whole. So, what is the basic difference between a data scientist and a business analyst? A data scientist can automate report generation, accelerate data extraction, and enhance business decision making, whereas a data business analyst can do the database design, return of investment, financial planning, and risk management. Based on the comparison table, also, we can see the different comparisons between the data scientist and business analyst. In summary, both data scientists and business analysts play crucial roles in driving business success. They have distinct areas of focus. Business analysts concentrate on database design, return of investment analysis, and financial planning, whereas data scientists focus on automating report generation, accelerating data extraction, and enhancing business decisions. Understanding this difference is essential for organization to leverage the strength of each role and drive the growth. Collaboration with business analysts. Data scientists help business analysts extract larger data sets and perform faster analysis. And they also make faster decision making to respond quickly to changing market conditions. So, the major takeaways are data analyst and business analyst form a cross functional team to leverage their unique skills. And the clear communication is crucial for successful collaboration. And synergy leads to emergent insights that drive business success. Collaboration between data scientists and business analysts is essential for driving business success. By understanding the theoretical underpinnings of this collaboration, organization can unlock synergy and achieve smarter, faster insights. So, my dear learners, I think like you might have got a clear understanding what is the different aspects of data science and what are the different job roles responsibilities in real world, so you can dive in deeper into this particular technology. Thank you for watching the video. Thank you.